Hi everyone. As I am getting ready to go back into the classroom as a virtual teacher, I'm thinking about all the parents who are trying to be teachers or help their students in math. And I wanted to address a question that I've heard several people ask in my years of teaching, and that is, why don't they teach kids to multiply the way I learned how to do it when I was in school? And I want to go through how it's taught, how it was taught, how it sometimes is taught now, the algorithm, and then why it's important to learn that way so that when you get to algebra, it makes a little more sense and you're able to understand. So let's look at a basic multiplication problem. A three-digit number times a two-digit number, 243 times 17. And I'm just gonna walk through the multiplication of this as I learned it, and as many of you probably do it when you're doing multiplication longhand when you don't have a calculator. So 7 times 3 is 21. You're going to carry your 2. 4 times 7 is 28, plus 2 is 30. 7 times 2 is 14, plus 3 is 17. And then you're going to do a placeholder. 3 times 1 is 3. 4 times 1 is 4. 2 times 1 is 2. And then you add. And you get 1, 3, 1, so it's 4,131. That's the way many of us learned how to multiply. When we teach students now about multiplying, generally they learn a different way of visualizing it. So we're going to break this 243 down into its component parts. So the 2 is actually not a 2, it represents 200. The 4 represents 40. And the 3 represents 3 ones. And then this 1 represents a 10, and the 7 is 7 ones. So we've still got the same thing here. This is your 243, and here's your 17 down the side. And then we're going to multiply. We're just going to, in each cell, we're going to multiply the row times the column. So 200 times 10 is 2,000. 40 times 10 is 400. 3 times 10 is 30. 7 times 200 is 1,400. 7 times 40 is 280. 7 times 3 is 21. And then you can do a couple of things here. You can add this way. So this would be 2,430. I can't do this one in my head. Let's do it this way. Well, 1,400, 1,600, 1,680, 1,700. I think it's 1,701. And then your product is 4,131. Either of those ways works to multiply. The reason that we like students to learn the box method when they begin to learn to multiply, number one, it sort of is a better understanding of what you're actually doing when you're multiplying here. It's the same process, but it makes the algorithm, it makes the actual math behind it a little more clear. But what happens is when we get to algebra and we teach students how to multiply using multiply polynomials, in this case it's a binomial times a binomial. If we were going to do this the old-fashioned way, the standard way, we would just stack the two on top of each other, and then we would multiply. 7 times negative 2 is negative 14. 7 times 3x is 21x. And then bring down my placeholder. Negative 2 times x is negative 2x. And x times 3x is 3x squared. And then we would just add. So 3x squared plus 19x minus 14. So that's how we get the product of those two binomials. Many students will learn this as FOIL, first, outer, inner, last. Sometimes, so first term times first term, outer terms, inner terms, and last terms like that. Sometimes teachers will teach it as a smiley face method, like this. And then you end up with a little smiley face. But really, the best way to understand it is just to use that box method that we just did back here with this multiplication to extend that forward into multiplying the binomial times the binomial. So we're going to break the x plus 7 down into its component parts, x plus 7 here, And then we're going to break the 3x minus 7 down into its parts. 3x minus 7 here, 3x minus 2. 3x minus 2 here. And then we're going to multiply just like we did with the straight multiplication problem. The rows times a column for each cell. So 3x times x is 3x squared. 3x plus 7 is 21x. Negative 2 times x is negative 2x. And negative 2 times positive 7 is negative 14. And then we look for like terms. So this 3x squared, there's nothing that we can combine, so it ends up just 3x squared. And then the two terms here in the middle are like terms, so we can combine these two. Negative 2x plus 21x is plus 19x. And then the negative 14 stands on its own. There's nothing to combine it to. So there's two different ways of looking at the multiplying. Now you may say, well, I still don't, this way may still make more sense to you, and that's all well and good. The reason that this is helpful to learn the box method is because once students learn how to multiply, the next thing they're going to learn how to do is to factor. Factoring is a really important strategy in solving a quadratic equation. So suppose we wanted to know what the value of x is in this quadratic equation. So I want to know what value that I can plug in, I can substitute in for x to make that equation true. In other words, what value could I square, multiply by 3, then add 19 times that value, then subtract 14 and get 0. So when we teach students to factor, we do the box method in reverse. So we know we're going to put a 3x squared here because there's no other x squared terms, and our constant's going to go down here in the bottom right corner. Now the question is, how are we going to break down this 19x into these two boxes? And mathematically, I could write it in a number of ways. I could rewrite 10x as 19x as 10x and 9x, and I could put those in the two boxes. I could rewrite it as 11x and 8x. I could rewrite it as 2x and 17x. There are lots of different ways I can break down this 19x to fill in these two remaining boxes. But the way we teach students to do it in algebra is we use what's called the AC method. So what we want to do is we want to find two numbers that multiply to give us the product of 3 and negative 14. So we're looking for two numbers that multiply to give us negative 42 and that add to give us positive 19. So two numbers that multiply to give us negative 42 and add to give us positive 19. And in order to do this, I'm just going to think about the ways I can multiply and get negative 42. So I could have negative 1 and 42, or I can have 1 and 42. I can multiply negative 2 and 21, or 2 and negative 21. I can multiply negative 3 and 14, or 3 and negative 14. And I can multiply negative 6 and 7, or 6 and negative 7. Any of those ways I can multiply and get a product of negative 42. But only one of those pairs will give me the sum of 19 that I need. I want it to sum to give me 19, and only this pair here will give me a sum of 19. So that's what I like to call my magic pair. That is the pair that I'm going to use over here in my box method to continue my factoring. So it's not going to matter, so I'm going to break this positive 19 down into a negative 2x and a positive 21x. Now, if you remember, that's what we had here, right? This is what we got right here. But when you're factoring, you don't know what that magic pair is. All you have is this initial equation. So you're trying to figure out what that pair is. So now we're going to put, and it doesn't matter whether you put the negative 2x here and the positive 21x here, or you can reverse it. Either way works. Then once we get to this point, what we're going to do is we're going to look at the rows and the columns, and we're going to figure out, we're going to factor out common factors. So if I look at this row here going across, I want to know what factor those two terms have in common. Well, 3 and 21 have a 3 in common, and they also have an x in common. So I'm going to factor out a 3x, and that's all you do. Then I'm going to look at the second row, and I'm going to think, okay, what do these two have in common? They both have a negative, and they both have a factor of 2. Then I want to look at my rows, or sorry, my columns. So I want to look at this column and think, what do these two numbers have in common? What do these two terms have in common? They don't share a negative sign, but they do share an x, a common factor of x. And then I want to look at the second column and think, what do these two have in common? They don't have a negative sign in common, so I'm going to keep a positive, and they have a 7 in common. I can factor a 7 is a factor of 21, and 7 is a factor of 14. And so what I've actually done here is I have factored this quadratic expression. I have broken it down into its two component factors. So it factors to be x plus 7 times 3x minus 2. Now notice that's what I started with here, but when I'm factoring, I don't know what this is. The goal is to get back to this. You don't know what it was, you just know what the quadratic was. So then now once we get to here, we've factored that quadratic, and we're still looking to see what makes that quadratic equal to 0. And I know that when I multiply any two numbers and get a product of 0, one of those numbers has to be equal to 0. In other words, if I tell you I'm thinking of a number 3 times a number that gives me a product of 0, that number that I'm thinking of has to be 0. There's no way I could get a product of 0 without one of my numbers that I'm multiplying, one of the factors being 0. So that's how you solve the quadratic. I have two options in this case. X plus 7, whatever makes that 0 could be one of my solutions. And you know from your simple algebra that you subtract 7 from both sides, and x equals negative 7. So one of my solutions is x equals negative 7. And then the other solution would be the value of x that makes that second factor equal to 0. So if I want to solve this equation, I add 2 to both sides. 3x equals 2. Divide both sides by 3. So my other solution is 2/3. So I've solved that quadratic equation. One of my solutions is x equals negative 7. The other solution is x equals 2/3. So if I go back into my original quadratic equation here, if I substitute in negative 7 in for x here and here, then when I do the calculation, my answer, if you will, is 0. Same thing with 2/3. If I substitute 2/3 in for x here and here, then when I do the math, I would get a value of 0 for that quadratic. And that is kind of a simple explanation of why it's so important for students to learn the box method when they're multiplying in 4th and 5th grade, because when they get to algebra, if that's the way they learn it, then it's a little bit easier for them to understand the math behind factoring a quadratic, which is a very important skill for Algebra 1 and Algebra 2. I hope you found this helpful. If you're struggling with something with your students and you would like for me to explain it from the standpoint of a parent and a teacher, then I would be happy to do that. Just send me an email and I'd be happy to see what I can help you out with. Thanks a lot.